Unit 8, Methods and Classes. So I already went ahead and make my Unit 8 package, and I already created a class called Methods. It's a little tricky here because it's a class and it's called Methods. That's because we'll be looking mainly at the methods portion of a class. I have two instance variables here. They're both private, and this value is an int. This gravity is a double, but something that's significant as it pertains to methods is the fact that this variable is static and this variable is not static. How do I know? Because I don't see the word static here. This is important, as we're going to see later. Some methods can be static and some methods can be non-static. Okay, and we'll talk about that. We'll look at the method overall picture. We'll walk through this. Then we'll come down and talk about static versus non-static. And then when we are finished with those, we're going to write some methods. We're going to have a bunch of exercises. Some of them we're going to write as static methods. Some we're going to write as non-static methods. I have them all stubbed out below. They're not finished. They're just stubbed out. The method signature is there. We'll talk about that as well. And then at the very end, we have the ever famous, well-known main method. Okay? Can't have an app without it. In here, we'll demonstrate how to call these methods inside the main to make sure that they're working properly. So let's get started. First, let's look at what a method is. So a method is an action that the object or class performs. See, that's where the static and non-static comes in. If it's the object that's performing the method, it's non-static. The method is non-static. If it's the class that's performing it, then it becomes a static method. And of course, we got to review, an object is an instance of a class. So if the instance is performing the action, it's a non-static action. If the class is performing the action, then it's a static one. General method format. How does a method look? I know we've been seeing these, but it's good to go ahead and look back over them. And first one is the access modifier. That's the first word. The second is the return type. Then comes the method name. Then we have an open parenthesis, and inside here is a list of parameters. It's written like this with dot, 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 because this could be as many parameters as needed. Close parameter, close parenthesis, I should say, and then no semicolon here. Okay, this is known as the method header or the method signature. If you ask a question, you have to get a clear understanding what the method signature is in order to write it. And the code goes inside here called the method body. It's a block. Code occur in blocks. This and that, stat and stop. Inside here is where you put all your code. But this could be returning something or not. And let me just make this clear. If it's not returning something, the type is void. The keyword is void. If not, it could be int, boolean, string, double. You get the picture. Any type can be here. Our access modifier for now is going to be public starting off, but access modifiers can be private, public, or protected. Private, you don't have access outside the class. So if I'm creating this class, for example, and I make a method private, that method only operates inside this class, not outside. Public, obviously, is access outside the class. Protected, it's a little tricky one here. We're not going to necessarily do this one, but this one is kind of public, private. It's kind of like a tweener. So one easy example would be a group. If you have a Instagram group, Facebook group, some group, that data or that method could be protected. It's private to everybody else outside the group, but public to the group. That's like an in-betweener. So this return type is next. This is all data type, or it can be void. No data type. This is a keyword void. That means nothing is being returned. Now you could return, you could say return and then semicolon. You can't say return int, return double, return some value. You could just simply write the word return in there and not return a value per se, and that's okay. But void is one of the types that you can have there. The method name, we're going to choose a good name, an appropriate name that said what the method does. If you look at the name, you should get an idea what it does. And the list of parameters could be all data types, or you could have no parameters. That's literally how the general format of a method looks. Now there are two types of methods, the main types, static method and a non-static method. The static method is called the class method. It uses the keyword static and only access static instance variables. That's what we want to show first. You see, gravity is static, value is not, value is non-static. Then we have a non-static method. It's called an instance method. Why is it called an instance method? Because the object performs this one. It does not use the keyword static and it has access to all the instance variables. So non-static method has access to both. Static methods only have access to the static variables. Let's see that in code. Suppose I want to print the value and the gravity in a non-static method. Let's do that. System dot out dot print. So I'm going to print the value here and the gravity. Okay, so value. I'm going to make them all into a string. Right? I'm just going to put a plus, a space there, and gravity. Now you see it prints the value and the gravity. You can see the gravity kind of italicized. That's how static method, or static variables, I should say, look. Methods as well. But once you look at the gravity here, you can see kind of leaning on the side, whereas the value is kind of straight up. That's how you know it's a static quantity. Now we have the printing of, not gravity, but gravity. We have the printing of gravity and the value. So let's go ahead and try doing that. Copy. Now I want to print the gravity and the value. Well, wait a minute. What happened there? I'm going to switch them around just to match the method name. Oh, what happened there? Well, you see, this cannot make a static reference to a non-static field, and that field is an instance variable. The blue ones, they have many names. They have attributes, fields, instance variables, same thing. These guys up here. You can't get access to a non-static variable if you are a static method. Let me say it again. If you're a static method, access to a non-static variable is forbidden. But if you're non-static, you have access to all. Let that one sink in. If you're not a static method, no issue. But once you become a static method, you only have access to static variables. See, a little error here. So I'm going to comment this out. The next one here is print the gravity. Okay, well, let's try doing that. So let me get rid of this one. Perfectly okay. Right? Perfectly okay because it's a static method and it's a static variable. No issue. Okay? That's a big difference between static and non-static and as it pertains to methods. Okay? A static method has access to static variables. A non-static method has access to everything. So one of the things you got to be careful with then is if you're creating a variable, and we're not going to dig into the static versus non-static variables for now. I'm just relating this stuff to the method. Okay, so if a method is static, it has access to a static variable, not access to a non-static one. But if a method is non-static, I mean the keyword static is missing, it has access to everything. Now, if I come down here, we have some exercises. And we have this: write a method called sum that takes in two integer parameters, find their sum and returns the sum as an integer, and it's a non-static method. So you can see this is how the information is going to be presented. You can pause the video at any time and write these methods. I'm going to go ahead and stub them out down. Well, they're already stubbed out. I'm going to go ahead and fill in the stubs. Right now, if you ask to write a method, which I will ask you to write a method, it's going to be very descriptive. And you just have to read the method, figure out all the pieces, put it together. So let me go ahead and write all these methods. So I have them all in order already and everything is all set up. I want to show something before I start filling them out. The first thing I want to show is precondition and postcondition. Precondition is literally saying what needs to be true before the method runs. Postcondition, you guessed it, what needs to be true after the method runs. So what needs to be true before it runs? the two integers x and y, these two, and the sum of them do not exceed or do not create an overflow because of exceeding the 4 bytes of on an integer. So shouldn't say 4 byte size on an integer. I should say 4 byte size. I think we all know what that is. So because we don't want to overflow this, we're going to make sure that the values that are going to be used are going to be small enough that we don't have any issue. We don't have the integer too big that it can't fit. Okay, because that's possible. So we got to make sure we keep track of that. All right, so I'm going to get rid of the on an integer because at this point we all should know 4 bytes is an integer, 8 is a double. All right, so now I'm going to go ahead and fill in the stubs. So let's do this. Now, this thing says return the sum, so it's pretty simple. You write the word return, and you return the sum. As easy as that. That's the first method. I mean, methods are not always this straightforward, but when we're first starting out, we want to get a feel for it, so we're going to write very straightforward, simple methods, just sticking true to the form. So here is the signature. It's public. Okay, we're writing all public methods. That's what it says up here. And so we're not going to worry about the access modifier. The return type is int. Okay. If you add two integers, you're going to get a sum that's an integer. So that's what we got here. Product, same idea. Let's return. This time is x times y. At this point, and that's not a time, that's an 8. At this point, you should be saying, wait a minute, I could do division. I could do a subtraction, right? You just write the thing and say subtract or something. And then go ahead and write x minus y. So is even is the next one. We have an integer coming in called a. Now let me just talk about these brown. These brown variables, okay? Those are local variables. Let me go up to the top. These are global variables. There's a scope issue. We'll dig into this a little bit later in the course, but this blue and this blue variable, quite different to the brown ones. These brown variables are absolutely deleted from RAM as soon as this method is finished. They're created 4 bytes each, 4. This calculation occurs. That's the reason why we need a return. And you should say return to where? Wherever it was called. And we'll talk about calling these methods later. So wherever this gets called, this value, the sum, is returned, and you can do whatever you want with it. X and Y does not exist after this method is finished. They're completely erased from memory. I'm going to go down and write is even. So I could say if a mod 2 is 0, return true. That's an even number. Otherwise, return false. Okay. If you have a method that asks you about, say, is something, generally is suggests a Boolean is coming back because it's either even or it's not. So it's true or false. So is a given away here. If you see a method says is visible. That's true or false. Okay. So is resizable. This is the type of method that you know it's coming back as a Boolean, and it has an if and an else. If it's straightforward like this, where simply, you check this and see if it's true, and if it's true, you return true, and then if it's not true, you return false. You don't have to write it this way. You can very simply return the condition, because the condition itself is a Boolean. That's true or false. So instead of writing it this way, I'm going to go ahead and take this out and put it at the top to say it can be done this way, or we could just simply return the condition, this, because that's true or false. And we're done. Is prime. How do you know if this number is prime? Well, it's prime if the only two things that divides it is 1 in itself. So why don't I, and this precondition said this is bigger than 0. So we got to make sure. So here we go. If b is 1, we're going to return false because that's not prime. Okay. Else, if b is 2, we're going to return true. Otherwise, oh look, I'm writing this so that we could see. If a 1 comes in, that's not a prime number. If a 2 comes in, it is. If it's any other number, I can go ahead and write a loop. Now, I could write a loop from the start of 2, but I'm writing this so that in case you are thinking about how to figure out this prime, I'm kind of getting the 1 and 2 out of the way, and then I'm going to write a loop for the rest. So for int I equals. Now I'm going to go from 3, I less than b, I plus plus. Why am I doing less than b? Because b is the value I'm looking at. So I want to look at starting from 3, going up to the value just before b. Is there any number in there that divides it? So if b mod I is equal to 0, we're going to return false. Look carefully, okay? I know I have a lot of returns and yet it's telling me, hey, you have an error, you didn't return. You know why? Because these are inside these ifs. So if this is not true and this is not true and so on, and this is not true, then that means none of this stuff happens, and so this thing didn't return. So here's what I'm saying. If it's a 1, it's not prime. If it's a 2, it is prime. Otherwise, check to see any other number if it's prime or not. Right? So you might say, well, wait a minute. What if the number is a 3? 3 mod 3 is 0. You may say, well, wait a minute. Wouldn't that cause a problem? No. Because if the number is a 3, the loop will not run. Because it would say, is 3 less than 3? No. That's the whole point of this. Because you see, it might not happen. So, if this did not happen, this did not happen, and this did not happen, the number has to be prime. Now, you could say, wait a minute. Do we need the 2? No, we don't. We could take this out. And we could start at 2. Okay, so start number. So you say, oh, what happens with 2? Start number 2. So what happens with 2? Well, if 2 comes in, this is not going to run. Right? It's not a 1. Comes in. It says it's a 2. Is it true? No, this is not going to run at all. It comes out of the else and it returns true, and 2 is prime. All right, the next one we're going to do is count down, and you see how this looks. Okay. This is an algorithm that requires me to think about, it wasn't so easy to think about all the pieces. It wasn't so easy for me to write this like this. So that's why I was showing you the 2 different ways. Is if it requires more, you can't just simply return that. But when it's basic like this, where it's just one condition, you could just return the condition itself. Here's a countdown. We did this one on the quiz. We just didn't write it as a method. Really, it's void. There is nothing coming back. It's just printing. Precondition. The value is greater than 0. So it could be 1. Okay. Now here's the thing. This value was up at the top. Look at that. It's a scope issue. The value up here is blue, but the value down here is brown. Well, what's up with that? That's because this value is not the same as the value up there. This is called a local variable. Actually, the guys inside the parameters are called dummy variables. Their job is to pass a value, as you will see when we call these methods. So I'm going to write the countdown for int I equals to the value. That's where we're starting from. I is supposed to be greater than or equal to 0, and then I minus minus. I'm going to print them vertically. You did this on the quiz before, just that we didn't say write a method. So if you look carefully, you've written that. Specifically, the value was 10. Specifically, the value was 10. But in this method, it gives me flexibility. I can call this method with 10. I could call it with 15. I could call it with 12. Any number I can call it with, as long as it's a positive number, and it will count down. So now, I'm going to go down to print the prime numbers from the lower bound to the upper bound. I'm going to do these vertically as well. So for int I equals to the lower bound, I less than or equal to the upper bound, I plus plus. You see, this is getting a lot more flexible here. Okay, so this one doesn't have a return type. So it's saying, hey, you need a return type. It's void. How do I know? Because I'm printing. Nothing's coming back. I'm going to say if, look carefully now, is prime. Then print it. So you see, this method is static. You can tell. You see how it's italicized? See how it's twisted on the side? That's one way to call a method. You call the method by simply putting its name here and filling in any parameters. So the parameter that's expected here is an int. So I'm saying start at the lower bound with I, stop at the upper bound. So realize the lower bound must be less than the upper bound, although this would make sense. Then plus plus. So it starts off, let's say we're going from 2 to 80. We start with 2. Is it prime? It says yes. It prints it. Then it goes plus plus. The 3 comes in. Is it prime? Yes. It prints it, and so on. It's going to go all the way up to 80 and find all the primes. It's a nice way of looking at things where a method helps another method. So, for example, this guy is helping this guy. All right, we have an average. Be careful here. We have int A, B, C, and D, and we want to return a double. So what do we need first? The sum. So I'm going to write a double sum. Well, I didn't write int. Why didn't I write int? Because if you divide to integers, you will lose the decimal portion. I wrote a sum as a double. This is not possible because you can't assign an int to a double, but the system turns this sum into a double and stores it. So now this sum is something 0.0. Then I could return the sum divided by 4. Why 4? Because it's 4 of them coming in here. Okay? And then this average here is non-static. All right, finally we have a method down here and it says count the vowels in the string. What? How do you count the vowels? Well, it's actually pretty simple. So for int I equal to 0, I less than str.length, the length of the string, I plus plus. Don't remember this from before? Again, on the good review. So here's what I'm going to say now. If, so I'm going to take the character first. So let me take the character. I'm going to call it character. And I'm going to say str.character at I. I want the character at I. So I'm going to say if the character is equal to A. Okay, so I'm going to copy this and put it here. If the character is A, or the character is B, not B, A, E, or the character is A, E, I, or the character is O, or the character is U. If that's true, then we need to count this and then return the count. Well, we need a count. How are we going to store this? We need to start a count at 0. And then we're going to say count plus plus. Actually, we don't need these curly braces, but I'm going to leave them. And at the very end, we're going to return the count. I have a count. It's going to store every time a vowel is found, it's going to update the count. So we're going to look starting at 0, stopping at the length. We're going to check every single character. Check to see if it's an A, E, I, O, or U. And if it's any one of those, it's an OR. Okay, it's an OR, so any one of those would work. It counts at 1. Then it returns them. What happens if this never works? Meaning there is no A, there is no E, there is no I, like the word gym. Well, it returns 0, and it's correct because gym has no vowels. All right, so now calling these methods. So if you're calling a static method, you would use the name of the class. But if you're calling a non-static method, you have to use an object. So here we go. Remember, the name of the class is methods. I'm going to make a methods object equals new methods. At this point, you should be very familiar with this. So this is needed to call all non-static methods. But the name of the class is needed to call the static one. See, I just hit the dot and it shows me I could say is prime. So it's putting 3 here. And let's print it. Right? I print, is it true that 3 is prime? Let's run it. It says, yeah, 3 is prime. What about 20? Is 20 prime? Let's check that out. No, 20 is not prime. All right, we just found the is prime. Let me go ahead and try something else. How about if I try calling the sum? I want to print them all so I can show that they work. So copy that. Let me just say, hey, object, could you do the sum of 3 and 5? So just so we know, the 3 and the 5, let's go back up and take a look. In the method signature, for the sum, 3 would be the x, 5 would be the y. Temporarily and very temporarily, x is 3 and y is 5. Those two values gets passed in here, added up, and we're returning 8. Let's run that. See? Now, I'm going to call all these methods. So I'm going to do product. Product is static. Product is static. So I can't say object dot. Instead, I got to say methods dot product. See the difference? I'm going to use 3 and 5 again so we can get 15. See the big difference there? Let me run that. So we got 8 and 15. Now, so I'm going static, non-static, static, non-static. I'm toggling back and forth here. The next method to call after product is even. That's non-static. So how would I write that? Well, I have to ask the object to do that one for me. Is this thing even the number 10? It should say yes, true. Run it. See, 8, 15, it is even. What's the next method? I'm going back and forth here. So is even, and then is prime. We already did that, and now that was static. And now we're going countdown. Well, let's do our famous countdown. Why not? We already have that. Let me do our famous countdown. Now that's non-static, so we got to use the object to do that. Hey, why don't you count down from 10? Right? Let's stick with the quiz. So it should say 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. Now, this is the big deal here. So you see how I did a print? See, nothing was being returned. Let's go look at the countdown. Nothing was being returned with countdown. It's void. So I can't print the countdown. I just simply call the countdown. So, see, I can't print the print. So I got to get rid of the print. And when I run it, it's going to count down. Now you can look at all the different methods. The ones that actually have something to return, I can print, but this has nothing to return. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Count all the way down to 0. All right, next one that we want to call, so you should be getting the idea at this point, is print all primes. So let me go ahead and do the same thing that I said here. So this one is going to be methods. I think it's static. Print all primes, right? So the lower bound is going to be 2, and upper bound is going to be 80, like we said. And it's going to print all the primes. See, right here. Starts off with 2, 3, 5, 7, 11, and so on. And then after we finish printing all the primes, we're going to do some average here. So the average for 4 things. So average, is that static? Nope, it's not static. So I need the object to do it. This one returns a value, so I could go ahead and print it. Let's go with average. If you call the method properly, it would put the spots where the values need to go. So let's do the average of 2, 5, 7, and 10. Whatever that average is, that's it. Well, the average is 6.0. Is that right? Let's see if that's true. 10 plus 7 is 17. 17 plus 2, 19, 24. Yes, 6. All right, last one is count the vowels. So let's make up a word here that has some vowels in it. It's returning the count, so we're gonna call it, and it's non-static. It's non-static. All right, should have been static. It said static here. Let me just write static. Let's make it static. Since it's static, I have to say methods. Okay, so methods dot, and what's the name? Count vowels. All right, we gotta come up with a string with some vowels in it. So let's see. I'm gonna make the string cannot. So we have 1, 2. So it should give me a 2. Let's see, right after the 6.0 should be a 2. I counted 1. Let's see if we make a mistake. Count vowels is counting 1. Let's see if we made a mistake. So starting at 0, count plus plus, character is a E, I, O. Oh, I think out of 0. Look at that. Mistake. All right, let's see. 2. All right, so quick recap. Methods could be static or non-static. If it's static, you're using the class. That's why a method is an action that either the class performs or the object performs. Class performing it, it's static. Objects doing it, it's non-static. We have to be careful when writing methods that have return types. Make sure that the type comes back, the exact type. So if we come expecting a double coming back, make sure a double is coming back. I should actually be real careful here and put 4.0, just to make sure that it's a double divided by a double. Gets a double coming back. All right. This is writing methods. In our next project, we will actually be using these ideas to write our app. We will also be using classes to write our apps, because what's a class? Well, the class is the object's definition. So we got to make sure that we can write proper classes using proper methods. Again, this is the format of the method, general format, access modifier, return type, method name, parameters. Maybe we have some parameters, maybe we don't. Maybe we return, maybe we don't. Or I got to show that last piece before we wrap up. So even if a method does not expect a return type, you could return. So for example, if void here means return nothing, which is what I'm doing here. Okay? We don't normally do this, but sometimes we may need this to get out of the method. Let's say we have a condition that says if this is true, stop the whole method. If the method does not have a return type here, we can just return. So like if I try to return a 2 though, it's going to have an error, because now I'm returning an integer when it says don't return anything. Okay, so the word return can be used in 2 ways. We can return without something, that's void, or we can return an actual value. All right, that brings us to the end of methods and classes.